Okay, in this part, we will indeed find what is going on with this P0118 code. Despite having a new coolant temperature sensor, I did get the intake manifold removed. I found that to be the easiest way. There were a lot of comments. One, I think, mentioned that you can remove the throttle body and access the coolant temperature sensor, which there is two of them, by the way. I have confirmed. I will show you. That did not actually end up working nearly according to plan. It was a lot quicker to just go ahead and remove the intake, but the trick is we knew we needed to do that. And that's also one of the reasons why this is also a two-part series. Obviously, we don't yet know what the issue is, but if this was a one-part series and I had shown what the issue is, it would be amazing how many people would have said they would have found it so much quicker, so much more rapid, without all the fancy equipment and electrical diagnostics. I would have fixed that in 5 minutes. It is fascinating. If you look back at part one, you won't see any comments that say that, because we didn't mention what the problem is. That only ever happens when I mention what the issue is. It's amazing. But there are also a lot of good legitimate questions, very, very frequent questions on why this system works if there is a shared sensor return. How does it know what the coolant temperature sensor is reading versus all the other shared sensors on that return? And it's because it doesn't read on the return, but I will explain that fully. We also explain this fully on my 5-volt reference video over on my paid content channel. We explain it very thoroughly there, but I will go ahead and fully detail exactly how this system works. Just so that everybody can understand that, because it is the most frequent question. Is a lot of questions on the design of this system and how it works. So what we're going to do now is I have confirmed there are indeed, as expected, two coolant temperature sensors. It does appear to me one was replaced and one wasn't. I'm thinking they replaced the wrong one. But whatever the case is, let's take a look. Let's do some more testing. Also, I misspoke in the previous video. There was another comment that brought that up. I had erroneously stated when I grounded out the PCM pin for the engine coolant temperature output that this validates the PCM and the wiring integrity to the sensor. That is actually incorrect. I did not do any wire integrity testing. We will do that now. But what I did do is confirm the PCM works. But I did misspeak on that, so my apologies if that threw you and you know what's going on here. And if you don't, that's okay. We're going to fully explain this system at the end of this video. Let's go ahead right now and just figure out what's wrong. All right, so if we look right here, that is a very good view. You can see we do have two coolant temperature sensors. Now, I'm not sure which one is which, but this, they do look identical. They look absolutely identical. I'm actually thinking they're probably interchangeable, which would be a really great way to do some of our testing here. So I think the first thing I'm gonna do is, let's keep this real simple. Let's get a DVOM. All right, and I'm expecting, usually you get around 10,000 ohms or so on a cold sensor. This is obviously gonna be a cold sensor now. I'm going to check this back sensor here again. I don't know which one is which. They certainly do seem interchangeable. Of course, another way I could do this would be very simply to swap the connectors and see that we get a reading on the scan tool, but not on the gauge. That would be an easy way of doing this as well. If you didn't know how to use a DVOM, if you are watching this channel, of course you know how to use a DVOM. All right, so if we read here, is that showing up in camera? Okay, you can see we read about 9,500 ohms on that sensor there. I'm going to say that sensor is working. That is going to be the one for the gauge, I will bet. We're going to read this one, and it reads 0. This is a failed sensor. This sensor is bad. Possible also, of course, we have a wiring problem too. We can very easy check that wiring integrity. First of all, I'm curious, do these coolant temperature sensor connectors interchange? That one fits that one. See if it fits this other sensor, the bad one. Oh, actually they are different, it seems. Boy, it's still kind of hard to get to. No, these connectors are different. Okay, that's interesting. So the sensors are different. I'll have to keep that in mind, make sure I get the correct one. when I buy the new one. Okay, so that one's for the gauge. That means this connector right here, this guy is going to be for the PCM. So what we're going to do to test this, it's going to be very simple. Going to get our scan tool right here, go to our data stream. Let's go to engine coolant temperature. There it is. We've got voltage and the actual temperature. We should, of course, still be reading, especially now, -40 and 4.6 volts because it's disconnected. And let's see if that's showing up in camera here. There we go. And I am going to grab a paper clip. All right, now in my last video, I had mentioned that I had lost my same paper clip I have been using for almost 8 years now and had to replace it, and only one person mentioned any sympathy for that. I'm just shocked by that. And now my new paper clip is part of a bucket of like 500 of them, so it's not special anymore. I mean, that is so sad, and nobody cares. But what I'm going to do is we're going to do this. You're going to short out the PCM. Yeah, I know. All right, and as you see, there's our wire integrity test. When I short circuit it, we see we read 253 degrees. This is exactly the opposite of the open. So on a short circuit, you'll read 253 like that. This confirms not only, of course, our wiring integrity, but also the PCM as well. This is only a bad sensor. All right, so I need to run to the store. We've got to get a new sensor, make sure I get the correct one, of course, and we'll have to get some gaskets for the intake manifold as well here. Pretty sure this is the correct sensor, brand new one. And what we're going to do to test this out is very simply, I'm going to connect in the brand new sensor, and look at that, 63 degrees. That is a fix. Now, the only thing is, will this also fix the hard starting problem? And I do believe it will. This is what I believe the issue is with the hard start problem. Okay, so as we remember, the hard starting problems seem to only happen when the engine is warm. And of course, one of the first things I thought is maybe we've got some issues with vacuum leaks or whatever. The fuel trim clearly proved otherwise. There's a question why the fuel trim was good too, by the way. But the reason for the hard starting when the engine was warm. When the engine is cold, you need extra fuel to start up the engine. Well, of course, the engine is reading cold already because of the open in that CTS right there. So you are getting probably more fuel than necessary, but on the cold engine start, it works just fine. Now on a hot engine start, you do not need the extra pulse width modulation to the fuel injectors to get the engine started. So you don't need as much fuel. Because when the engine is cranking, it's reading -40 degrees. The PCM thinks the engine is still really cold, and therefore it is adding the extra fuel. The reason the engine won't start, therefore, is actually because it's flooding. It's too rich. That's also why I was able to get the engine started by putting a little bit of the throttle on. By opening the throttle, we lean that out and the engine is able to start much better. So that is the reason for the hard start. Now this does bring up a question. Why did our fuel trims look normal then? Shouldn't we have had rich fuel trims with the PCM seeing the -40? And I believe the reason is because with the PCM seeing the open circuit code, it does not consider the engine coolant temperature data. And it's probably reading off either the IAT or using some other parameters or something, maybe some kind of substitute code or something. And as you can see, it clearly works fairly well because we do not have rich conditions on the engine, despite the fact the PCM would see -40 degrees on the engine. So I think it just doesn't use the data while running, but I do believe it used it while cranking, which is the reason for the hard start. I am very confident we will see the hard start problem disappear. So what we're going to do now is I'll get this back together. I've got a couple other things I got to do first, but we'll get this back together. We'll show that the hard start problem is resolved, and then we will talk about the design of this system so that you fully understand why we got the results that we got, why the scan tool shows what it is, how I was confused about the 5-volt reference, and then it's actually a little more confusing when you find that that's not a shared 5-volt reference, it's a shared ground actually, and how with a shared signal return, how is the signal from the coolant temperature sensor differentiated from anything else? Again, it's because it's not read from that. There were some comments that were mostly correct, but a little bit incorrect. I have seen some designs like what I assumed, where you have a shared 5-volt reference to the sensors, but the return is where it is read. I will also show that design as well. It is not true that you always have an exclusive reference to a temperature sensor. I have personally seen cars that do have the design that I thought I had interpreted from the wire diagram. So we will make all that clear. First, let's verify this car is fully fixed with the hard start. We're going to have to do a little change in plan here actually, because the coolant temperature sensor that I got actually turns out to be the wrong one. I guess I should have checked first, but the threading on the new one is a little bit different. Still fits with the connector, but the threading is different. So I have to get another sensor. It's not going to come in for a few hours. I kind of don't want to hold up the video just to see the final fix by then, because I got to fly out for a business meeting. So what we're going to do is we're just going to go over to the dry erase board of knowledge, and we're going to talk about the sensor system, how this works. And then if I have time, I will show the final fix with the hard starting being resolved. Most likely I'll just have to put a little appendum at the end of this video showing that the hard start was resolved. If the hard start isn't resolved, we get another video, by the way. So let's head over to the dry erase board of knowledge and let's understand the system. All right, again, this is explained in way more detail on my 5-volt reference system video, which is on my website at www.schrodingersboxqm.com. It's explained in much more detail than we'll do here. Also, the basic electrical series discusses this. And as a matter of fact, the previous video that I did, where we helped the automotive technician student, the auto tech student, with their ASE exam for basic electrical. We also touch a little bit on this concept as well in that previous video on this channel, but it's really the 5-volt reference video that would really be the one to watch. But what we're going to do is we're going to show how this system actually works and answer the questions on how can this system work if it has a shared signal return. We will explain that very clear. And then also what I will do is show the system that I thought that it was, which is still a valid system. Contrary to popular belief, you can have a shared 5-volt reference on thermistors. You can, and I will show you how that design works, as a matter of fact. So the way this system works, we'll make it a little bit simpler. So we're going to simplify this just a little bit. We can show 2 thermistor systems on here. There's actually a lot of things shared on this sensor ground actually, but let's get a IAT and the coolant temperature sensor as well on here. So what we're going to have is the PCM. This is the way this system actually works. We'll have the IAT here. We've got a whole bunch of other things. As you saw, we had like 50 million wires on this PCM. We also have a CTS in there. All right, from there, we have, and actually we forgot, we got to draw the magic. This is where the magic is. And I explain this in much more detail. If you're not familiar with this concept, we're going to draw the IAT here, CTS here, and the magic with it is there is an internal resistor in the PCM on each of these. Then we've got 5 volts and 5 volts separately in this case. There will also be lots of other things with lots of other 5 volts out here that will still share in this system. We're just going to use these 2 for simplicity. Okay, so this is going to go off into the IAT. All right, and that's going to be a thermistor, of course. So we've, of course, got a variable resistor in there. Now, of course, if you know your basic electrical, then you know the reason for this internal 5-volt reference resistor inside the PCM, of course, so that you can get your voltage drop, which is actually, I should draw this a little more accurately. We're going to make that more internal here. And what it does is it measures the voltage drop across that resistor internal in the PCM. This is like a little DVOM here. And it's going to measure the voltage drop across that resistor. Now you see, I hope, the importance of this internal resistor here. The reason being because if we didn't have the internal resistor in here, well then if we read the DVOM against ground, we're always going to read 5 volts no matter what the variable resistor shows. This measures voltage drop. It does not measure current. Measures voltage drop. Well, we would not have voltage drop except across here in the resistor, and that voltage drop would always be a complete voltage drop. Again, I explained this in detail otherwise. I'm assuming you know this, but that's the reason why we have the resistor here, because now our variable resistor will create a varying resistance between here and before this resistor, and that DVOM is measuring the voltage drop across this resistor, which will change according to that variable resistor. All right, we also have the same thing here, and this is the coolant temperature sensor. All right, same thing, we have a variable resistor in here, and then we'll draw in green, we have our grounds, which are shared and returned back to the PCM. Should have planned out my PCM a little bit better here. Right there into the signal return. And we see that signal return is shared. We actually have, as we saw on the diagram, many other things that also shared at that point on the signal return, all sharing that same signal return. This signal return here is simply a ground. There is no measurement off of it, and that's the reason why the shared signal return, we can still differentiate between the IAT and CTS, because it is not measured from the signal return, as some of you guys had thought. It is measured individually with individual DVOMs. There's another DVOM here that measures the voltage drop for the CTS across that internal resistor. All right, so that is the design on this particular system. Now, of course, when I initially just looked at the wire diagram and being familiar with 5-volt reference, when I had seen this here, this big junction, well, I thought it was a different design where basically we've got the 5-volt reference that is shared with a whole bunch of sensors, and then the signal return would be measured. That would be a different setup, okay? The way that would work, and there are systems like this, we would have our PCM here. All right, and we're going to just do one 5-volt reference. All right, now that 5-volt reference is going to come out. Now, we may not have an internal resistor in here because we are not going to measure from this 5-volt reference. Now, this 5-volt reference is going to split off to feed a whole bunch of other sensors. What else might be on here? EGR position maybe on here, all kinds of other things. But 2 of these will be shared here. One of these is going to be the CTS, and then for our simplicity here, the other one we're going to do the IAT. All right, now as before, the CTS, of course, is going to have a variable resistor, the IAT also, a thermistor, variable resistor. Those are terrible looking symbols. Let me draw those a little bit better. All right, we're going to do the IAT and the CTS here. All right, in here is a variable resistor. In here is a variable resistor. And now each of these is going to have a separate ground, a separate signal return. Okay, this is going to be a signal return on the IAT. This is going to be a signal return on the coolant temperature sensor. And of course, now you see, I hope, we need the magic in here. We need a resistor in here and in here. And we see that it works now the same exact way. What we're going to do is this is going to be a ground here and a ground here, but because we have the variable resistor here and a resistor here, we are going to have a variable voltage drop across this resistor because of the variance we will see on this side of the resistor thanks to our variable resistance in our thermistor. So we would have a DVOM here that measures voltage drop across that resistor. Same thing here, a DVOM that measures voltage drop separately across that resistor. Therefore, it is possible, as you can see, to share a common 5-volt reference on two thermistors simultaneously because you're going to read them using the same principle, just only on individual ground sides. Okay, I do not recall vehicles where I've seen this design specifically. I know that I've seen them though. I know that I absolutely have seen this design, and as you can see, it's fully reasonable design. It's really kind of no different. The one thing about having your 5-volt reference as I drew it though, and we again cover this in the 5-volt reference video, is there is a little bit of a risk with this setup here where if any sensor shorts out, you will bring down your entire 5-volt reference system. This will probably cause a no start on the car. So for example, with this CTS, okay, well, we saw that what actually happened in this CTS is that we have an open. That open, of course, is not going to affect the rest of our 5-volt reference system. Now, if we had some kind of issue where this 5-volt reference internally or even externally shorted to ground, well, if we get a ground short on that, that brings the entire system to ground. All your sensors would be disabled as they have no 5-volt reference voltage at all because all that voltage would be dropped to 0 as we pull to ground. So the design here, you can see the one reason that maybe a lot of cars don't use this would be because this would cause a cranking no start situation as none of your sensors would be functional. One other issue you can see is you've got to find where that short to ground is. And one of the first things that you may try doing is disconnecting every single sensor on that shared circuit and then seeing if your 5-volt reference returns as you disconnect one of them. That would indicate that you have a shorted sensor, and replacing that sensor would fix the issue. Now disconnect all your sensors and you still have no 5-volt reference voltage. Well, now you got to do some short finding, right? And the car won't start until you find it. All right, so hopefully that helps explain again. For much more detailed explanation of how this works, I will put a link to my video on my website, and that is on my paid channel. Videos there are much more detailed in explanation. It is $3.49 a month. You can watch hundreds and hundreds and hundreds of hours of this stuff. All right, what we're going to do now is I've got a lot of other things I'm going to do on this car. I'm going to try to get you a final fix video showing that the hard start is repaired as a result of the coolant temperature sensor. If I'm unable to do that, I'll just have to put a tag at the end of this video, and we'll see you next time. So hopefully I'll be back.